Hi everyone, so we're back and today we will be learning how to name ionic compounds. So, what is an ion exactly? If you can recall, ion is, when you say ion, it is any compound, any atom or group of atoms that bears one or more positive or negative electrical charges, atoms, or electrical charges. So this ion can have either cation, the positive electrical charge, and an anion, the negative electrical charge. So an ion is an atom or group of atoms where the number of electrons is not equal to the number of protons. So if you can recall from the previous video about solving for protons, neutrons, and electrons, the formula for solving the electron is the number of electron is equal to the number of proton minus the charge. So if it's an ionic compound, it says that the number of electron is not equal to the number of proton. If we can also recall, this number of proton here is the atomic number, right? So if this is the case, the number of electron is not equal to the number of proton, meaning it has to have a charge. So it can either be positively charged or negatively charged. So some fun facts about naming ionic compounds is that ionic compounds can have high melting points, and they require high temperature to melt, and they tend to be hard and brittle. So most cations and anions can combine to form solid compounds, like for example NaCl, okay, or salt. So the first thing you want to do here in naming ionic compounds is um, name the cation first, followed by the anion. So name the cation first, the positively charged ion. So you name that first. So let's say we have NaCl. Say we What if we have NaCl? We know that the cation here is the sodium. So we write sodium. Okay? And then we know that the anion here is the chlorine. So now we have the second step, which is to name the anion by removing its suffix and change it to IDE. IDE. So the name for this, let's go back here. We have sodium chloride. That's the simplest example. So what if we have cations that take on multiple charges? So for example, transition metals. So if when we look at transition metals, I have this very helpful periodic table of polyatomic ions here. We have several ions here. And what if we have transition metals. So transition metals are around here. If you can see my cursor, the transition metals are around here. And as I've said earlier, they can take more than two or more than one charge. Okay? So I also have another periodic table which can be found this one. Um, so this also has charges. So this is the periodic table of elements, and the one I showed you earlier was for the periodic table of ions. So this is the most basic periodic table, and it's also complete. So I'm going to give an example here, and let's go back here. We have, so what if we have TiBr3? So Ti, or titanium, is a transition metal. We have titanium here. So the titanium can actually have four positive or three positive. And the bromine, if we look at the this periodic table, bromine can have +5, +3, +1, +5, +3, +1, and -1. So there are many choices for bromine, but we know that since titanium is a cation, bromine have to be an anion, so it should have a negative charge. Sorry, this is actually -1. So here we name this by naming the first step. We have titanium. This is the first step, naming the cation first. Titanium. Then we have bromine. Since we picked this one, it's an anion, so this will become bromide. Please don't be confused since there are polyatomic ions that is either bromite or bromate. So this one is not a polyatomic ion. This is an ion. Ion. So then observe that we have the subscript 3 here. Okay? So we can say that titanium might have 3 positive here, and since our bromine is negatively charged as we pick, it needs 3 subscript for it to become a stable ionic compound. So when we say stable, the net charge of this ionic compound is equal to 0. So this is the net charge. So this is titanium 3 bromide. Okay, I hope that's clear. We have titanium 3 bromide. Another example would be um here, let's get back here. We have titanium 3 bromide. In other words, we need 3 -3 charge so that the net charge of the ionic compound is 0. So for another example, let's say we have GaAs. So Ga is gallium and As is arsenic. So in our periodic table, Ga or gallium is positively charged, and it's the charge for this is positive 3. And arsenic is can be positive 5, either positive 5, positive 3, or negative 3. So As can have either positive 5, positive 3, or negative. So this is fixed. The gallium is our cation, so we name this first gallium, and we know that we want negative 3 to be our superscript for it to be positive 3 plus negative 3 equals 0 or 0 net charge. So we do not leave this here since it can be gallium, can be um, gallium only has a positive 3 charge. So we can directly write this as gallium arsenide. So actually, if you look at the periodic table of ions, arsenic or arsenide can only take up negative 3 for this. So, however, in our periodic table of elements, it can take up several charges. So this periodic table of ions here is very helpful, and I'll attach it to the description below later. So let's proceed to the third example. So this one is BeHCO3. So this might intimidate some of you, but if you're not familiar, this enclosed in parenthesis is called a polyatomic ion. Polyatomic ion. So what is a polyatomic ion? Polyatomic ions are also known as molecular ions, a covalently bonded set of two or more atoms of a neutral complex that can be considered to behave as a single unit. So they behave as one. This one, polyatomic ions, is a family. This type of ion is a family. So they are said to have a net charge of 0. So let's check if they indeed have a net charge of 0. So we have H. We know that H is positive 1, and our I mean our O is surely negative 2. So C must have been negative 1. So plus 1 minus 2 is equal to, no, this carbon here should have a positive charge. If we can check in our periodic table, sorry. So it can take up to different charges here in this very advanced periodic table. But when if we check our our periodic table of ions, C can only have, no, it can have positive 1 since carbon is not an ion. It can have positive 1 charge. So 1 plus 1 minus 2 is equal to 0. So this polyatomic ion here has a net charge of 0 and they are treated as a single unit. So let's get back to naming this type of ionic compounds. So beryllium has a, let's check the charge for beryllium. I think it's positive 2. Beryllium. Yes, it has a positive 2 charge. And so let's just write this down. Beryllium, beryllium is fixed to have a positive 2 charge, while HCO3, this polyatomic uh, ion here, this can be called a hydrogen carbonate, but is also known as bicarbonate. Let's check. It's polyatomic ions here. We have we're looking for HCO3. HCO3 is hydrogen carbonate. That's correct. It's hydrogen carbonate, and it has a minus charge. This polyatomic has a minor minus charge. So what I have said earlier is that this enclosed has a zero charge for all. It has a net charge for 0, okay? But this, if we treat this as a single unit, it can have several charges. So it depends on what polyatomic ion it is. So now we have beryllium bicarbonate, or I'm just going to write this down. It can be can be named as hydrogen carbonate, or in short term, bicarbonate. So we have beryllium bicarbonate, and for this compound to to have a net charge of 0, we take up BeHCO3. 2. We bring down the 2 here. It means that we need a negative 2 for this to be equal to 0. So how do we name this? We name this as beryllium bicarbonate. There's no need to actually write down the charge for beryllium since it is fixed that Be on, is not a transition metal. This is not a transition metal. This cation has a solar charge of positive 2. So we just write beryllium bicarbonate. For the fourth example, we have PbSO4. So this is, so we know that, check your periodic table on your own. So we have Pb can have either 4 positive or 2 positive. This lead is a transition metal. And we know that from the polyatomic ion table, they know that SO4 is a sulfate. This is an ion sulfate, which means that it has SO4 and has a charge of SO4. So um, SO4 has a charge of 2. Sulfate has a charge of negative 2. And if we can confirm, the lead can have 4, positive 4 or positive 2 charge here, this number 82. So sulfate actually has a 2 minus charge. So what do you think we will need for this? So in order for us to have a net charge of 0, since this is given that sulfate actually have a 2 negative charge, we want to have the Pb to have a positive charge, so that negative 2 plus 2 equals 0 net charge. Therefore, we name this first as lead positive 2, this is Roman numeral 2, sulfate. So there is an exemption for polyatomic ions to have to be exempted in step 2. We don't call this beryllium bicarbonide. We retain the name of the polyatomic ion. So we don't call this lead 2 sulfide, since this is not an anion, but it is a polyatomic ion. So there are some exemptions for this. So examples 3 and 4 are exemptions, since we have this enclosed in parentheses, the polyatomic ions. And examples 1 and 2 are more simpler examples of ionic compounds. The next video will be on naming covalent compounds. Thank you for watching.